Let's take an exhaustive look at the bi-chorus effect. For this example, I have a short noise burst. If you look at my mixer, I'm just using noise, and the amp has the sustain and break all the way down with a decay time of 20, which is 44 milliseconds. The decay slope is also at its hardest for an exponential curve, and that is going through the effect, the bi-chorus effect. Let's look at the effect itself. Right now, by the way, here's the dry sound, so you can hear what that noise burst sounds like by itself. And if you look on the right, when I'm not talking, you can see that the transient on this meter here. In fact, let me put this on transient mode, so you can see that short little burst there. And then, of course, when I talk, you can hear my voice. Unfortunately, I have to record. I always record through the Kronos, and I have to record out of the stereo output, which is also what feeds OBS. So you'll have to deal with seeing my voice through the metering here. Anyway, let's turn this up to 50-50, dry wet, and let's get into a little explaining here. So this unit has different modes, and it's just different ways of routing. And so you can choose between serial and dual. Dual itself has two modes as well, stereo and mono. Let's focus on serial for now, and let's look at the routing diagram. So this is serial right here. And you can see that it takes the signal input and it sums it to mono to be processed by each chorus effect or each delay line. And then that delay has a feedback parameter. And then at the end of that process, it is sent out of the left and right stereo output. These bars at the top and bottom are the dry signal, and then the summed processed version is the wet. So right now we're at 50-50 dry wet, and let's hear what it sounds like. We know we're going through this first delay line, or this first chorus unit, and then we're going to be going through the second one. And the parameter that I want to go over right now is the manual control. It goes from 0 to 100 in series. And let's turn the second delay on 0 and see what that looks like. So of course we see two transients because it's being delayed. So when I turn up the second delay in this serial configuration, do you think we'll hear two different transients? We do not. We only see one. And the reason for that kind of threw me for a loop when I first saw it. I didn't understand why. And you might think it's because I have the delay time for each at the same value, which is not it. In fact, I could change the delay time and we'll still only see two transients. And actually look at what happens when I move the second delay time down. And back up. You saw that it made the second transient happen sooner, and then when I moved it back up, it happened later. So what's happening is by feeding the signal into this unit is technically on 100% wet, and then that's feeding directly into a second 100% wet delay. So it's delaying a delay. It doesn't create multiple delays. What it does is it just creates a single delay that is longer, because all we're doing is technically adding more time with the second delay. And I mimicked that with the master effects, so I can show you exactly what's going on. If I go to my routing, route to the left-right, and then the left-right is, of course, going to the output. And then if you look at my insert effects, I'm sending to master effect 1. And so this is master effect 1, which is being routed through master effect 2 in a serial configuration, or in series. And then it's being blended with the original left-right signal. And of course, each of these master effects is at 100% wet, which makes it by default 50-50, which is just like how we had the 50-50 dry wet of the bi-chorus effect. For the master effects, I am using mod delays because I want to show what's happening with something besides, the same effect unit. And an important thing to note here is that this 0 to 100 time control, manual time control, This is not a measurement of milliseconds. This is a percentage of 25 milliseconds. So if you were at 50, I haven't tested this exactly, but I'm pretty sure if you were at 50, it would be equivalent to 12.5 milliseconds. So if you have 25 milliseconds here with a value of 100, and you have 25 milliseconds here with a value of 100, then together you have a 50 millisecond delay. I'm mimicking that in the master effects by having a 25 millisecond delay and another 25 millisecond delay. And let's double check to make sure that we are routing to the left, right. Yep, going to the master effects. So let's hear what that sounds like. We get 2 transients. And if I switch between the master effects sends, or in other words, the left, right, versus the bi-chorus effect, you can see that they have the same exact time. So here's the bi-chorus effect, and then the master effect sends. And I'll just switch between them back and forth. You can see that's the exact same distance for both. Now, if I go to the master effects and I take down the second delay time, which is only stacking on top of the first because they're in series, then we can see that we'll have closer transients, just like I demonstrated before. And that is exactly the same as going into the second chorus and moving that down to 0. And again, I can switch back and forth between them so you can see the difference. Here's the bi-chorus distance and the master effects end distance. Of course, there's a volume difference. I can't exactly explain that. I don't know everything, but I just wanted to demonstrate exactly what's happening with this serial configuration.